So now let's look at different numeration systems, starting with Roman. So I expect you to know how to read those, and for that you just have to know what each letter stands for. So M would be stands for 1,000, and then of course you need to understand rules. D for 500. Then what else we have? C for 100, L for 50, X for 10, and this for 1. Okay, sometimes like this. Okay, so we knowing this, we can look at the example we have and say, okay, normally the Romans organized the numbers from the bigger to the smaller, right? But if the smaller is before the bigger, that's kind of like a subtraction. So what I mean by that, first you see M. Okay, that's thousands. I have 1,000. Then I see, so that's like okay, 1,000. Okay, then normally D is 500 and C is 100. So normally like bigger should be before smaller. So but if you see this order reversed, smaller 100 is before the bigger, that means 100 less than 500, which this stands for 400. Okay, now again, normally you would see X is 10 and C is 100. So if the smaller is before the bigger, then that means the subtraction. So that's 10 less than 100, so that's 90. And same here, since X is 10, but before it we have smaller 1, that means 9. So that's 1,499. Okay, let's kind of see if we can read the next one. Okay, M is 1,000. So I know this number will be 1,000. But now D is 500, okay? And then 100 and 100, so that's total 700. Because I count how many hundreds I have, right? Then L is 50, and then I have 10, 10, 10, so that's 50 plus 30, 3 tenths, so that's 80. And then I have 5 and 3, so that's 8. So I count how many hundreds I have, how many tens I have, and how many units I have, right? 1,788. Okay? So let's look at the different bases. So if one of the question will be convert from the base, say here, a 5, into the number in base 10, so our system, right? Okay, so that's the easier way, because all we need to do now is just simply understand how the different base works. And how the different base works, that whatever number you're given in whatever base, you understand that this is number of units. This is number of, well, depending on what base you are, in this case 5. This would be the number of 5 squares, which would, if we remember the concrete model, 5 represents longs, 5 squares would be 5 by 5, so that would be flat, and 5 cubed, if we have one more digit, that would be a block, right? So each digit first is units, number of 5s, numbers of 5 squared. So that means we have 4 times 5 squared, 3 times 5, and 4 units. And that's just once when you calculate it, you're gonna get the answer. So here will be 100 plus 15 plus 419, right? So that number is the same as 119 in our kind of system, in the system using base 10. Okay. Well, the other way around is a little bit more complicated. So now I give you 14 in our system in base 10, and I want you to convert it into base 2. So the algorithm we develop is simply, if the base is 2, I'm just going to keep dividing by 2 and recording quotient and the remainder. So basically, how many times 2 fits into the number and what's the remainder, okay? So 2 fits 7 times into 14, and the remainder is 0 because it fits fully into 14. So again, divide 7 by 2. 2 fits 3 times into 7. 2 times 3 is 6, so the remainder is 1. Again, keep dividing by 2 as long as you can. 3 divided by 2 is 1 because 2 fits once into 3. And 2 times 1 is 2, so what's still left? Subtract that from 3, and what still remains is 1. And of course, this is not divisible by, is smaller by 2, so you cannot fit 2 in it. So you have your number, just bring it up. So the number 14 converted into base 2 would be 1110. So again, that number goes first, and then the rest follow. So 1110. And if you have any doubts, you can check the other way around. What's that number? Remember, that's number of units, that number of 2's, that's number of 2 squares, and that's number of 2 cubes. So you have 1 2 cubed, 1 2 squared, and 1 2, 0 units. So 8 plus 4 plus 2, so that amounts to 14. That's correct, right? So I checked backwards. If I were given the number 1110 and base 2, I could easily check that this is 14. Okay, let's do this exercise 2 more times with different bases to practice. So first, the easier way, I'm giving the base 3 and convert to base 10. So this is number of units. I'm in base 3, so this is number of 3's. This is number of 3 squares. So I have 2 3 squares, 1 3, and 2 units. So that's 2 times 9, 18, plus 5, so 23. So that's 23 in base 10. So now the other way around, I'm giving the number in base 5, the number is in our base 10, and I need to convert to base 5. So I'll be dividing by 5, and you might want to use a calculator for that if you don't see it. So how many times 5 fits into 233? You can divide 233 by 5, and you will get 46.6. You record the quotient only, 46, and then you see to figure it out what's the remainder, you do, so 5 times 46, because you said that's how many times it fits, that's going to be 230, so you know the remainder is 3, okay? Right, because that's 3 away from 233. Then you divide by 5 again, so 46 divided by 5, I know it's 9. 9 times 5 is 45, so that's 1 away from 46. The remainder is 1. Then you still divide by 5. 5 fits once into 9. The remainder is 4, right? And 1, well, it's too small to fit 5 in it, so we're done. And you bring the number up, which then gives you that 233 is the same as 1413 in base 5. If you have time and wanted to check if you did that correctly, so you go from the other side, will that end up being 233? Well, this is number of units, this is number of 5's, this is number of 5 squares, this is number of 5 cubes. If you have time to do it, and that should give you 4 times 25. This is 5 and 3 8, so that's combined 233. Yes, so I checked that I did that correctly. Okay, and let's do this problem one more time, this time using base 12. So this is in base 12, the only thing is that in every base we use 1 less than the base digits, that many digits. So for example, in base 10, I use digits 0, 1, 2 up to 9. In base 5, I use digits 0, 1, 2, 3, 4. In base 2, I only use digits 0, 1. So in base 12, I need digits representing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I represent 10 by T and 11 by E, right? So this is number of units, this is number of 12s, and this is number of 12 squared. So 5TE in base 12 is the same as 5 times 12 squared plus 10 times 12, T stands for 10, and then 11 units. So that's 5 times 144, this is 120 plus 11. So we're gonna end up with 851, okay, in base in our base 10. Okay, so let's convert the other way around. Let's convert the base 10 number 49 into the base 3. So I'll keep dividing by 3, okay? You can use a calculator for it. You can check what's 49 divided by 3, and you would get that that's 16. And 3 times 16, you can check it's 48, which means it's one below 49, right? So the remainder is 1. You keep dividing by 3. 3 fits 5 times into 16. 3 times 5 is 15. That's 1 less from 16, so the remainder is 1. You still can fit 3 into 5 1 times. So 3 fits once into 5. 3 times 1 is 3, that's 2 away from 5, so the remainder is 2. And now 1 cannot fit 3 in it anymore, so you're done. And you got that 49 is the same as 1211 in base 3. Okay? And you have it. Okay, let's do the problem about finding numbers in the given base, one more and one less. So preceding meaning one less and succeeding meaning one more. So let's say we're in base 3. So preceding, another is saying one less. Well, and then succeeding one more. I suggest the best way is to visualize it, maybe to write it using flats, blocks, or longs or units. So here 1 0 0 means 0 units, 0 longs, and 1 flat. So I have 1 flat 3 by 3. Okay. Basically, that's what my number represents. 0 longs and 0 units. Okay, if I want to add, let's do a successor. If I want to just add 1 unit to it, well, that's easy, right? So that's gonna be this in base 3. I just added 1 unit, so that was easy. But now what's difficult is if you wanted to subtract, because if you wanted to subtract, you have no units to take away from, which means that this flat you need to decompose. What you can make of them, you can make of them 3 longs, 3 by 3, right? Make 3 longs, and then once you have 3 longs, you can then remove 1 long, remove 1, which means here you're gonna, this will be, so that one of the longs would have to be split into 3 units so that you can take 1 unit away, right? And so when you preceding number would be what? 2 longs and 2 units. So 2 2 in base 3. Okay, so I feel like that's easier to visualize. If you don't want to do the drawing, then you would have to think that way. This I borrow, this becomes 3 here, but then I borrow 1, so I have 2, I get 3 units, and I take 1 away, okay? So you can do that as well. Okay, let's do another number. So 1 less preceding and 1 more, the successor, okay? So here notice that the easier one in this part A is 1 more, because if I just want to add the unit, I add 1 unit in base 5. So at the end, digit at the end. 1 less is a problematic one, because right now actually I have this stands for, this is units, longs, the next one is flats, and then blocks. So I have 1 block. So now I have 5 by 5 block, right? 5 by 5 by 5. So 5 to the power 3. So I can decompose it into 5 flats, because imagine 5 flats together create a block. So if flats is 5 by 5, right? So now I take 1 block, creates 5 flats, 5 flats, 5 by 5. Okay. Now I remember need to take 1 unit away, so one of the flats, this one, the last one, I'll convert into 5 longs. Okay, but one of the longs I'll split into 5 units. Okay, so it's the same as we had originally. The combined number of units is the same, because I have 1 block, but 1 block is the same as 5 flats. 1 flat is the same as 5 longs, but 1 long is the same as 5 units. So now when I take 1 out, 1 unit out, notice I erased 1 unit. So now what I'm left with is 4 flats, 4 longs, and 4 units in base 5. Okay. Again, if you don't like drawing a picture, you can visualize it this way, that without the picture you say, okay, this becomes 5 flats, but then I need to borrow 1, so I'm left with 4 flats, and now 5 longs, but I need to borrow 1 long, so now I have 4 longs and 5 units, but I need to take 1 unit out, so I'm left with 4, 4, 4. Okay, so you can do that as well. Now let's do some parts B. So here 1 more and 1 less. So which one I started with? 1 less usually. 1 less and 1 more. So here in part B will be easier to do 1 less, because notice I have 3 units, so I can just take 1 unit out. Okay, so that's easier. 1 more is more tricky, because I cannot write 304 in base 4, because in base 4 I only have digits up to 3. Whenever I have 4, that becomes that 4 becomes 1 long. Well, so basically what happened here, if I add it to original number 303, when I add 1 unit, then I will get 4 units, but that then becomes 1 long. Whenever I group by 4 now, right? So that will be 310 in base 4. If you prefer to draw the picture, draw it. Original number 303 stands for 3 flats, 3 by 3. 0 longs and 3 units. If you add 1 unit, then you have 4 sorry, it's not 3 by 3, I said wrong. 4 by 4, right? We're in base 4. So those flats are 4 by 4. And then, so you have 3 flats, 4 by 4, because we're in the base 4, and 3 units. You added 1 unit, so that created 4 units. Whenever you have 4 units, they will become a long. So now you have 3 flats as you had originally, but 1 long and 0 units. Okay, let's look at this one. So again, 1 less. It's easy. 3, 2 in base 4. 1 more. Let's think of it. At this point, I'm in the base 4. I have 3 longs, 4 by 4. Sorry, not 4 by 3 longs. Of each long has 4 units, and then 3 units. And now I'm gonna want to add 1 more unit. So that means this unit, this unit will create a long, because 4 units form a long. Okay, but now 4 longs form a flat, because now I have 4 by 4, right? Flat. So that means that this will be 1 flat, 0 longs, 0 units. So 1 more will create this. Okay, and 2, 1 less, again easy, that's 2, 1, we're in base 3, but 1 more here is tricky part. So think again, in base 3 you have 2 longs, so long consists of 3 units, right? So you have 2 longs and 2 units. You're gonna add 1 unit to it, and that happens, whenever you group by 3 in base 3, that becomes a long. But now we have 3 longs, so they will become a flat like before. So what you end up again is 1 flat, 0 long, 0 units in base 3.